Hello everyone, I'm Caio Cefas, and this is a short explanatory video on the preliminary results. Enormous amount of constituents of petroleum makes the use of classical characterization methods for the crude oil composition by mole or mass fractions of individual components. Experimental data were provided in the form of distillation curves, which the temperature is plotted versus the vaporized percentile. So the first part of this work is to generate the oil pseudocomponents from a distillation curve, and for this we use the MATLAB software. In this approach we use the distillation curve presented by Koster and Hoffman 1996 and the methodology proposed by Caio book. So the graph here shows the distillation curve and its respective pseudocomponents created and represented by the blue rectangles, 21 in total, each of them described by a set of physical-chemical parameters like molar mass, boiling point, etc. Since the pseudocomponents were characterized, we move on to the next step of this work, which is the Aviva process simulation. And in this step, we convert the whole 21 pseudocomponents into two specific HDS process pseudocomponents, sulfur and sulfur-free oil. We add the source model to canvas, then we drag the oil fluid to the source and set the process variables. Now we use a calculation block called here lumping block to convert the 21 initial pseudocomponents into just two. For that, we must set the out fluid type to desired fluid. In this case, we use the fluid 2. It's important to mention that the required equations for this conversion were obtained from Riaz's book. Finally, we drag the sink to the canvas and connect the lumping block. As you can see, the feed stream originally with 21 components was converted into other one with just two components. After the conversion, the lumping block outlet stream can be fed into a hydrate desulfurization reactor as a subsequent step. Thank you very much for your attention and good conference.